Okay, good afternoon, everyone. Can you hear me okay? So my name is Henrik Nieminen, work as a solution architect with Econex, based here in Helsinki, but I work with our global partners and also with our global business development. And in that capacity, I'm also part of the ETSI MEC working group. So that's what I'm here to share with you today, a little bit what we do in that work and how I believe it will fit in with this, this forum. Which way should I point this one?
You just need to press it a bit longer.
There we go. So a little bit of background to this ETSI MEC work that we're doing, though. The requirements for the standardization of ETSI comes typically from organizations outside of ETSI, though. In this case, it's the 5G AA, or 5G Automotive Association. And they have built these various use cases. So this diagram here represents in total about 10 different use cases, if I'm not mistaken, related to traffic security and automotive use cases. So it's all about traffic information between cars in urban areas, between corners, redirecting traffic in case of congestions, or floodings like we had in Helsinki, was it 2 days ago? And also about traffic lights. So how do you better control the traffic lights so you can get a smoother traffic through towns, so you're more efficient about when you turn to red and green lights though. But if you look at those to your right there, you have two different network operators there, and both of them are having their own multi-access edge compute system there. So how do you get the connectivity between these two systems? That has not been that clear, though. And part of this white paper that we've been working on, we've been looking at the connectivity piece of it. So I'm going the wrong direction here. So zooming in a little bit on these two operators, you have operator A and you have operator B, and both of them are having their own MEC system. In this particular use case, you're having a car with app X connected to operator B. The application, however, is in operator A, so it has to connect in between. So the white paper is a lot about all the ETSI, MEC, the multi-access edge compute, interfaces, protocols. How does the user find the application that's running on MEC system? How do you enable that connectivity, etc. But then there's one important component that's quite often is missed in these standardization documents, and that's the connectivity between the operators. In the documentation, it's always solved as a magic yellow line, or like in this case, by a cloud that says a controlled IP network. So first question is, who controls it? Who owns it? And when you start to dig into it and start to kind of like demand some kind of answer to it, well, actually, we use internet. So how is internet controlled? So if we then dig down a little bit further, these are the requirements set by ETSI for how this controlled IP network should be done and what the requirements are. So I summarized them here. But number one requirement is really that you have to be able to discover MEC system between different providers. Well, internet can do that, but then it's not really controlled yet. The second one is that you have to be able to exchange information in a secure manner system in different, between MEC platforms in different systems, though. Now, internet doesn't really fulfill that requirement anymore. And thirdly, this connectivity have to also connect to application providers. And the applications are not only the MEC. Quite often, they live elsewhere. Quite often developed in the clouds, hyperscalers, or a third party that hosts that application, but then some compute functions need to be closer to where this happens. So when we're
I wonder why the internet is not any more secure, because we have TLS 1.3 and other mechanisms to secure it. Would it just be a land grab by some big corporations that want to make the system closed?
So there are those who want to make it closed. They want to have it as a, I'm going to get into that though, but they want to have it as a controlled environment. When you say that it is not secure over internet, well, it depends a little bit. You can secure it with different means, But if something happens to the routing, then you may not have that connectivity anymore.
We had a presentation here before how to secure routing.
Yeah.
So why not use the systems we already have in place and just not reinvent the wheel?
Let me get to that.
Okay.
So why don't we why reinvent the wheel? Why don't we use the systems that we have? So what we start to look at then, how do we realize this controlled network between this? We start to look at what are how does on a high level, the topological architecture look like. So down on your left, you're going to have the users, the cars that connects to these applications. They are connected to various operators, can be wireless network, can be wired, doesn't really matter. But these operators are then having the telco edge, as we call it, the multi-access edge compute system. If you're going to go from one network to another, you typically go through a carrier-neutral facility of sorts. And today, if you go like roaming, you have the GRXs or the roaming exchanges, you have your IP transits, you have your internet exchanges. And then also this is where you have connectivity to the clouds. So to look at a question, why should we reinvent something new? Well, that's kind of like what we're trying to avoid here. So if we look at it, what do we have in place today that could fulfill this controlled IP network? Well, we have the internet exchanges, and they are living in these carrier-neutral facilities. And most of the operators are already connected to it. So here we have looked at if you want to make it a dedicated function for certain applications, whether it's road safety or something else, then we have kind of like the environment there. And internet exchanges, I think, are well positioned for this, as you can create called the community peering or a VLAN for this part though. And so one thing that has been what we have meant in this white paper or created sort of the MEC Federation interconnection provider. Because these are things that are further ahead in time. I don't think we have seen any such deployment yet, but we think that this is most likely the way to go. And this is also probably where we need to have internet exchange providers on board on this thinking to looking at, okay, we do actually have platforms in place that can solve this today. And then we extend it to various others. So we have the automotive industry may want to be part of it. We have the public sector. I mean, if it's road safety, they want to have a visibility into it. We have the application providers and enterprises. And the way it sort of would work in the end then is we have the control plane. We can use the IXs. It's going to be a layer 2 functionality. And this is where the MEC Federation provider comes in, though, or a proxy player up to the top right, the blue one. So that will be sort of a hub and spoke architecture. So that's where you register your users, your MEC applications. I need to discover the application in operator A when I'm connected to operator B. He will tell me where to connect. And then we need to have something for the user plane, because in some cases we're talking about video surveillance as well. And that may be a lot of traffic from time to time, so we probably want to separate that from the signaling or the discovery part of it. So here we need to see how do we create that data plane. But here the MEC Federation provider, we're looking at doing API-enabled data plane or user plane functions so that they can then set up that connectivity between 2 operators or multiple operators where required, depending on the use case. So ask for you, this is from the Etsy side of things as well. We need more partners looking at how do we actually realize these kind of use cases? Because they're talking a lot about the network slicing. We create a slice for certain use cases. But if it goes out of the operator's network, what happens to that slice? So that's what we're trying to do it. The slice must go on. We extend it across systems, and we have that secure control environment for these specific use cases. So that's all from me. Thank you. And this is all the companies and people who are part of writing this Etsy white paper.
Hi, one question. When you say APIs, is there some certain APIs that you are sort of basing it on, or do you make a new API for it, or any ideas?
This is a bit of a question, though. So that's not really part of the standards side of things. That's the standards that Etsy is working on is a lot on the Etsy MEC side of things. How you do the APIs. Now, you're going to have to ask, who has this platform that can create this? What kind of APIs do they have? What do they expose? And that's still a lot of work to do to get there.
IX API? Maybe?
Maybe.
Any other questions?
So is this also part of the Gaia X initiative, or is it a
No,
global
this
one?
completely separated.
Okay, so it's not a European close, because this is then GDPR reason why a little bit not so great. Yeah, if we are speaking about civilians and so on, I see there a lot of US and Asian companies included here.
Yeah.
Is this problematic, or is GDPR just outside of the box? Because I see a lot of here hospital, I see civilians.
Yeah,
I'm not sure if this is.
So I think there are
fitting.
two things to it. So one is that this is run by the ETSI on the telecommunications side for the multi-access edge compute side of things.
Okay.
And for those standards, how do we get different providers, get the MEC systems to talk? Now we're going to get into the more complicated stuff with the use cases, GDPR, and how do you store all that, and how do you manage that data? That's kind of like a different topic compared to what this white paper was about.
Yeah, but I think a pretty similar approach is also done by Gaia X, which is an European Union thing.
Yeah.
I guess you exactly know what I mean. The Telos project and all those stuff, and I think they're yeah.
But Gaia X, is that from the data sovereignty side of things when you want to build a European
Yeah, but there are a
cloud
lot of work
initiative?
groups inside this Gaia
Yeah,
X. It's
correct.
just the whole thing. Yeah, and if it comes to those projects, I think a pretty similar project is the Telos project. I'm not sure. I'm not on Terra. Yeah, I also don't have it. The sub project, I don't have it in mind, the name. But there is one which is maybe exactly the same.
No, that would be
So
interesting to
I
follow.
just wanted to mention if this also fits with the Gaia X. Thanks.
It is not connected, but maybe it should be.
Are you going to be here for dinner and sauna?
For dinner at least.
So maybe you should definitely exchange information
Absolutely.
during dinner. Petri, did you want to ask any more?
I did not get the answer to my question, but if you want to discuss it further over dinner, that will be fine.
Sorry,
If you want to discuss it over dinner,
we can discuss over dinner as well. But yeah,
because I feel here that somebody has figured out something that is supposedly broken in the current IP networks, and I don't feel that way.
I would say that if you look at the IP control network, it's debatable whether internet fulfills that purpose, though.
Yes, but who needs to control it? It's an IP. It's an open IP network.
Yeah, it is.
If your network stack cannot take more than, say, 100 SYN packets per second, maybe you should fix the equipment and the operating system instead of putting firewalls and other controls in the cloud.
That could be one approach, possibly. We follow the MEC, the way they define the requirements for it. I would say that internet is not the platform for it. If you feel differently, I think you're more than welcome to join the ETSI group and influence that.
All right.
You don't know what you just did.
It can be a real shit show certain days. Right. Thank you.
Okay.